Hello, good afternoon to all the viewers of this video. Today we are going to talk about the concept of suspended process, why they were created and their advantages. The members who participate in the investigation and editing of this video are Diego Pedrozo and me, Kenn Marcucci. Well, let's start in the concept of suspended processes. We have a question. What's the suspended state of a process? A suspended process is a process that is not in main memory. A process that is not in main memory is not immediately available for execution, regardless of whether or not it is waiting for an event. When all processes in main memory are in the block state, the operating system can suspend a process by putting it in the suspended state and transferring it to disk. The space that is freed in main memory can be used to fetch another process. A process in suspended state has the following characteristics. First one, the process is not immediately available for execution. The second one is the process may or may not be waiting for an event. If so, the blocking condition is independent for the suspended condition. And if the event that blocks it occurs, this does not enable the process to execute immediately. The third one is the process was placed in a suspended state by an agent. Either the process itself, the parent process, or the operating system in order to prevent this execution. The last one is the process cannot be recovered from this state until the agent explicitly indicates so. I have a question. Why was the suspend state created? The suspend state of a process was created to avoid saturating main memory by suspending a process and transferring it to disk. Likewise, the space that is freed in main memory can be used to fetch another process. Suspended processes are born from the need to reduce idle time. To see this need, we are going to assume a system that does not use virtual memory. Each running process must be fully loaded into memory. The memory stores multiple processes, and the processor can be assigned to another process if the one using it crashes. The speed difference between the processor and the input outputs is such that it will be very common for the processes in memory to be waiting for these operations. Therefore, even in a multi-programmed system, the processor may be idle most of the time. Hence lies swapping, or the need for swap memory, which involves moving part or all the process from main memory to disk. When none of the processes in main memory are in the ready state, the operating system swaps one of the processes locked to disk in the suspend queue. This is a list of the existing processes that have been temporarily kicked out of main memory or suspended. The operating system brings another process from the suspended queue or responds to a request for a new process. The execution continues with the new process that have arrived.
Hi, I am Diego Pedrozo. I am here to talk to you about the advantages of use of the suspended state. The implementation of the suspended state brought with it advantages such as it allows freeing memory by suspending processes that are blocked, thus giving way to the possibility of bringing in new processes, improving system performance. It gives the possibility of avoiding system failure since if the operating system detects or suspects that there may be a problem. It can suspend processes and investigate the cause of the error. The operating system may require the suspension of a process in case such as swapping. The operating system needs to free up enough main memory to bring a process into a ready-to-run state. Avoid problems. The operating system may suspend a background or utility process or a process that it suspected was causing a problem. Interactive user prompt. A user may want to suspend execution of the program for debugging purpose or because a resource is being used. Timing. A process can be executed periodically, for example, a system statistic monitor process, and can be suspended while waiting for the next execution interval. Parent process request. A parent process may want to suspend the execution of the descendant to examine or modify the suspended process or to coordinate the activity of several descendant processes. One of the cases is presented with the interactive use of the system. For example, if users suspect a program has some kind of bug, they can stop running the program, examine and modify the program and its data, and resume it again. A parent process can suspend a child process. For example, process A launches process B to perform a read on a file. Subsequently, process B finds an error reading the file and reports it to process A. Process A suspends process B and investigates the cause.